Hello, welcome to my Tech Farm. I have a very special product for this video, and it is a Snapmaker 2.0. Now in email they told me that they will send me A350T version, but here on the box I can see A350ENT. So at this moment I'm not even 100% sure what is in box. And this is the biggest box I received so far. The weight is almost 50 kilograms and it is sent to me by the Snapmaker in exchange for a review. This is 3-in-1 product, so it is a 3D printer, CNC router and a laser engraver. The biggest difference between 350 and 250 is the print area or the volume. Here you can see the comparison for 3D printing, CNC routing and laser engraving. But for 3D printing, another big difference is that the bed can be heated up to 100 degrees Celsius on 250 version. On bigger version only to 80 degrees Celsius, so we can forget printing ABS, for example. But anyway, I am here in my basement because it is too big for my flat. And here the temperature is approximately 15-16 degrees Celsius, so definitely I will stay only with the PLA. About the laser, the power is 1.6 watts, so basically it is enough for, let's say, engraving the wood, but we can forget about its cutting. Well, actually for cutting we can use the CNC router. I'm not sure about its power, but I know the spindle can rotate between 6 and 12,000 rotations per minute. But other specifications you can see on the website. Let's see what's in the box. You will see packaging is very compact and everything is in separate boxes, protected good during the shipping. First I can see user manuals, and this is the first layer, linear rails, tools, tool heads. This is the second layer of the box. And then in this layer, actually these are parts of the enclosure, but I didn't realize that yet. And when I thought I was finished, actually there was one last layer, and that's the acrylic of the enclosure. The packaging is extremely nice, and I will not even unbox everything, only when I need it. I can see actually I get two quick start guides. One is for A350T, and the second is for the enclosure. I didn't know I will get the enclosure too. It is also very useful with this product because for printing it is quieter. For CNC routing, those chips or cotton parts will not fly all around. And also it will give some protection properly during the laser engraving. And these instructions are really fantastic, beautiful pictures. Only with one product I saw something similar, as the Prusa. So this user manual is fantastic, and I will follow this one. But I can see that there are actually videos how to assemble the machines. But I will use these steps. For example, this is 1, 2 from 24 steps to assemble the machine. I will not show here a very detailed assembling guide because user manual is very good, and also there are very good videos. I will show you just some assembling steps because here I can present you the quality of these products. So these are the linear modules for the y-axis, and I'm mounting the base of the printer. And then look at this. This is a screwdriver, which is also very good quality. Next are the holders for the Z-axis linear modules. And this is the holder for the screen. It will be screwed from the bottom. Everything is metallic so far. These are the linear modules. Pitch of them is 8 millimeters. They are for the Z-axis. Y-axis linear modules has the 20 millimeter pitch. First I am holding them from the back side, and then 4 bolts from the bottom, but they're not tight yet. It is very hard to move these holders of the Y and X. And this is the X-axis. The pitch here is also 20 millimeters to get higher speeds. They're also screwed from the back side. And after this I can tie the holders of the Z-axis from the back and from the bottom. After this I have to move higher the X-axis, which is very hard. And then I'm starting with the cable management. This is for the Y-axis and this is for Z. Actually it is a splitter because the same signal is split to the two Y-axis linear modules. and also with the Z-axis. And this is the main unit. All cables will be attached here, X, Y and Z. This is the screen. It is connected with USB-C port. And this is the power supply, and this is improved version, which is quiet. And this was the last step of assembling. I finished the assembling, and I can tell you that I enjoyed every 24 steps, because this really gives the feeling of the premium product. I don't know how it prints or engrave or the CNC machine so far, but the assembling was perfect. I mean, every hole and thread was on its place. I don't have to struggle with anything. So the user manual is very useful, and the assembling is very smooth. So far I'm very impressed with this machine. All parts are metallic, there are no plastic parts, not even injection molded, not 3D printed. It uses the linear rails inside, I cannot see them, and it uses the lead screws, so I'm not sure how fast is it. And I was afraid that the lead screw may have some backlash, but I cannot feel any kind of the backlash in this movement, so it will not have that kind of problems. Of course, now I have to continue the assembling to prepare it for the 3D printing. And maybe after that I will prepare the enclosure too, because it's quite cold here in the basement, and enclosure may be useful even for the PLA. It's time to prepare it for 3D printing, and this is the toolhead I have to use. This is the door if I want to feed the filament manually. And this is a spare nozzle with the heat break. It's pre-assembled, so it is very easy to replace it. And the toolhead will be held with these 4 bolts from the backside. This is the cable for the toolhead. And this is a spool holder, which I believe it could be a little bit better. Maybe some kind of rolling element would be nice, but it will do the job. This is the hotbed, and I think it will be good to have some kind of thermal insulation from the bottom, and I have to hold it with these 22 bolts, and this may be the reason why I will not swap too often between these operating modes, CNC and laser engraving. And this is two-sided build plate. It's flexible, of course, and it will be held by those magnets from the bottom. And this is the cable for the hotbed. And this is the holder of the cable for toolhead. And this is the power supply. It has some LED lights inside. It is very quiet so far. This is a timelapse of the booting. I think it could be a little bit faster. It needs almost half minutes to boot. This is 5-inch touchscreen with HD resolution and quad-core processor running an Android operation system. I don't have any kind of internet connection here, so I have to skip that part. The screen is very responsive, like I'm holding a smartphone or something like that. Calibrate the bed. Okay, let's start with that. And it is good to hear that it has those silent stepper motor drivers, because I know in previous version it was not silent. It was touching the 9 points, and I have to set the Z offset. This is between the nozzle and the paper with this calibration card. Loading the filament. This 1 kg black PLA was in the package, so I will use this. It's preheating the nozzle. I'm cutting the end under 45-degree angle, and then I'm feeding it over the screen. I can see it was tested with some blue filament previously. It says outdated firmware detected, so I have to refresh the firmware. Okay, let's do it, and also I prepare a G-code for printing. The software is Snapmaker Luban, and here I have these 3 modes, and I'm starting with 3D printing. I'm inserting a calibration cube on STL file, which will be my first printing. And if you are familiar with the Cura, then this will be very easy to use. Here we have some preset basic values, normal printing or fast printing. By changing this, basically there are some preset values which can be changed later here. So we have again here a little bit advanced settings. These are for the layer height, speeds, Model structure, I believe this is the infill and the number of the walls of the perimeters, support or don't want to use the support, and the adhesion type, skirt, brim or raft. And if you need a little bit more settings than this, we can go more settings, and here we can set quite a lot parameters. It is very similar to Cura. Generate G-code, and I will set this G-code to the provided USB disk. Let's update the firmware, going to Files, USB, there is the bin file. First 30 seconds nothing happened on the screen, but later in approximately 3 minutes the firmware was updated and I could continue with work. It was pleasant surprise to see the preview of the object. The bed will be heated up by default to 70 degrees Celsius. More than 12 minutes to heat up to 70 degrees Celsius, and only now it started with the printing. I know it's too cold here, it started for 13 degrees Celsius and Enclosure will help with this, but I think this heating up should be much faster. The start is good so far. Only the first layer was 70 degrees Celsius, now it's cooling down the bed to 50 degrees Celsius. These are all preset default settings for this PLA. And let's see how accurate is the remaining time. 32 minutes, this means approximately 12:41 minutes it should be finished. Printing is more than 50%. Between 43 and 46 decibels when it's moving faster, then it's 46, but when it's moving slower, when it's printing, then 43. And I will add this to my summary table of the noise from the 3D printers. Bed temperature between 50 and on the corners 45 degrees Celsius. That's quite equal. From the screen I'm missing the current Z coordinate. Here we can do some settings if we need to. The printing is finished and immediately I want to check the bed adhesion. Which is great. I hope not too great. I will wait until it cools down a little bit and then I will try to remove it. Total printing time was 33 minutes, which includes the 12 minutes of the heating, so this means that the predicted time in the slicer was accurate. The adhesion is really good. And the first thing I noticed on this calibration cube that there is no ghosting I usually see. Probably this is thanks to the rigid structure and using of the lead screw instead of the timing belts, which always has some micro elasticity. And the skirt. But maybe the bed adhesion is even too good, so definitely I will check that Z offset with the heated bed if possible. Even if I preheated the bed, it doesn't keep it on that temperature during the calibration, but at least the bed is not 12 degrees Celsius like on first calibration. And it's time for another printing. Benchy with the preview. The first layer goes down perfectly, but after approximately 5 minutes. Interesting situation, I was lucky that I was here. I heard that filament broke, so I will just try to remove the filament. Actually I will remove this part and insert the end of the filament. How can I do it? Maybe if I pause the printing it will offer this option. I just paused the print, but I cannot see possibilities for the replacing. Well, the only option would be the manual replacing. Let's resume. Interesting, I couldn't find the possibility how to replace the filament, not even after pausing the printing. Maybe I could do it manually by opening this door, but never mind, I will leave it. We will see if it will detect the end of the filament and suggest a replacement. Filament runout detected. Okay. Okay, that filament sensor is working now. Too much wobbling of the filament, maybe a rolling spool holder would be better. But it is very easy to DIY one because the shaft is very small. I noticed that the traction noise is a little bit louder than I get used to. Printing is finished in approximately 2 hours and 20 minutes with a 0.16 mm layer height. The bed already cooled down. Perfect. I think it still sticks too good to the bed, so next time I will use 2 pieces of the calibration card to set the Z offset. It's a little bit hard to show it in a black color, but this Benchy looks great. This is the bottom layer, top surface, perfect overhangs, the bridging, maybe just 2 strings if I can see on the whole printing, but even the seams are very hidden too. Only I can see a small line or maybe a spot here where I had that filament change, but otherwise, great Benchy. Not the fastest one, but looks good. And now filament change, I need to print something in white color, because my daughter has few more snowflakes on the Christmas tree. The filament change was smooth, I just followed the instructions from the screen. It's a snowflake from printables.com. The printing is finished and the bed temperature is 11 degrees Celsius. Nice clean printing. I mean, this is very easy for printing, but now the conclusions. I decided to measure the backlash. Here you can see I placed this dial indicator in X direction, and what are we looking for? If I move to the same 0,0 position from the left or from the right, I should get the same value. But here I can see the difference of approximately 0.05 millimeters. And then I measured everything in the Y direction too, and I got very similar results. If I move from the left, I got 0.05. From the right, it goes back to the 0.0 value. This is why I think that the lead screws are not really good for 3D printing linear motion. Timing belts are better, but of course this is 3-in-1. For CNC machining we need those lead screws because they can handle bigger loads too. And let's measure in Z direction too. Here that backlash was also presented minimally, but very small, 0.02 millimeters in this case. The Z lead screw has the pitch of 8 mm, until in X and Y direction the pitch was 20 mm for faster movement. And for curiosity, I measured everything on my Prusa Mark III's, which uses the timing belt on X-axis, and here you can see that theoretic backlash is only 0.01 mm, depend if I move from the left or from the right side to 0,0 position. So this is why timing belts are better for 3D printing. But of course they are not good for CNC machining. And I measured in Z direction too. Prusa also has the lead screw of 8 mm in Z direction, but those nuts are from POM and not from brass. And in this case that was accurate, 0,0 independent if I move from the bottom or from the top. These are just my first printings and my first thoughts about this printer. Well, I hope the Snapmaker will success in their business, because it is very good to see a Chinese company who tried to create a premium object, not just to put something together which works even if it is 95% finished, just push it on the market to be as cheap as possible. Here definitely that's not the case. Every part of it tells us that this is a premium product, not only the hardware but the screen, the provided tools, the software, everything is very nicely engineered and created. Now, I'll be honest with this printer, it is, don't forget, it is 3-in-1, but as a printer I would say it is like an average printer. Most disadvantage is maybe the speed. It cannot reach those speeds like those correct size printers with these lead screws, even if they have the pitch of 20 millimeters, but I don't think that's enough to get those speeds. Don't get me wrong, I mean it's fast like, I don't know, maybe Ender 3 or something like that, but definitely not comparable with those correct size printers, which may be in the same price range as this. Don't forget, this is 3-in-1 product. In firmware I can see also some possibilities for improvements. For example, during the printing I would like to see always the current Z coordinate. Also definitely during the printing I would like to see a separate dedicated button that I can replace the filament, because currently I can do it only by pausing the print and do it manually, opening this small door. This two-sided bed surface works great, maybe even too good. Sometimes the bed adhesion is too strong and it is very hard to remove the object. So definitely I would suggest you to first attempt try to use 2 pieces of this calibration card to get a little bit bigger Z offset, and if necessary then you can lower it, because otherwise I had some problems that sometimes it was very hard to remove the objects. Of course, for our luck it is good that it is flexible, but there is always a danger that maybe I will peel off part of the surface. Also, I really don't like that this bed heats up so slowly, and even then the 80 degrees Celsius is the maximum. So definitely in part 2 I will build the enclosure from the Snapmaker, and I will do some test prints inside. I will also try the spiral or vase mode printing, and of course I will try ABS, so we will see if those 80 degrees Celsius is enough, or maybe it's not really good for ABS printing. And of course after this I will print the CNC and the laser engravings in that second part. If you have some additional information, you can help me out, you know, through lines in the comment section. But thank you for watching and happy printing!